up the histogram of our results. It should be, that was them, this is you. Perfect, this is gonna work great. Okay, so what happens if this is given to you instead of the raw data? Can you actually get anything meaningful off of it? And John's nodding his head yes. He said yes. Is there any concession you have to make?
It's not like entirely accurate.
Good! We lose a little bit of precision more than accuracy, but nonetheless we lose something, don't we, Carolyn? Don't worry about accuracy and precision. We'll figure that out as we go through the class too together. Yes, we lose a little bit of something. And why do we lose a little bit of something?
We have to assume values.
We have to assume values, Jacob. There's values, for example, 13 of you had between 0 and 2 keys. But I don't know how many zeros, how many ones, or how many twos. Now, we know, because a little bit illegally, we know that, I think there were 7 of those were twos. I think it was 7 or 8 or some ridiculous number of twos. But we're going to assume that everybody in this actually had how many keys? I think we got as far as this last time, didn't we? We're going to assume that everybody actually has 1 key. Now, explain to me again the logic of that. Why was it okay to assume that everybody has 1 key? Why is that okay? Rachel, go!
Because you're not too far one way or the other.
Nice.
Right in the middle.
The assumption, and this does fall a little bit short, as Carolyn mentioned, but we have a fix for it, so don't worry about that. The assumption is that for every person that has 0 keys, there's somebody over here who has 2. Together, those 2 people have 1 key each. That's the assumption. So we're going to pair off this 0 with that 2. So if you look back at your data, the 1 0 at the end pairs off with the 2, the next 0 pairs off with the 2. What's the problem though? What assumption does that make?
That everything was even.
Boom! If there are 13 people in the group, let's make it 12 to make the math easier. It assumes that there are 4 zeros, 4 ones, and 4 twos. Which means each 0 pairs with a 2. Well, we know that's not true with our raw data, right? We know that there are only 2 zeros, I think, and like 7 twos. So this is actually what? An over or underestimate?
Under.
It's actually an underestimate. Now, we don't know that on our raw data, do we? We don't know that because we don't have our raw data. All we've got is this graph. So what we're going to do is we're going to assume it's evenly split. 4.3, 4.3, and 4.3 to give us 13. But that's a problem because we might be over or underestimating. But here, I'm going to plant this seed in your mind right now. We're going to come back to it. We underestimated here, yeah? What's probably going to happen over here?
Overestimate.
In one of those bars, on average, is going to be overestimated. On one of those bars, on average, is going to be just right. Now, how the hell can that be? How the hell can it be that if one of them is overestimated, on average, one of them is going to be underestimated, and one of them is going to be just fine? How the hell, on average, I'm saying. I'm not saying in every particular data set. How can I say that? It's pretty ballsy.
Because there's 3 outcomes and 3 data bars that we're looking at.
It's making me happy, Carolyn. There's actually, if you think about it, there are 9 possibilities for what could happen. Underestimate, underestimate, underestimate. Over, 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 just right, just right, just right. So if you put any 3 of those together, you get one of the 9 outcomes. The chance of all 3 of them being overestimated is 1 in 9. That's pretty small overall, if you think about it. Check. Sarah, ready to go.
Okay, so but what if we're talking about statistical probability and groupings in randomization?
Give me 10 minutes.
Okay.
I've got just that for you. I built one for you guys. Yes, I built you a randomization for you to prove the point and hopefully illustrate exactly what I'm talking about so you can see it dynamically. That's a great question. Say it one more time because the camera can hear you.
Okay, so what if you have to take into account statistical
Probabilities, I think you said.
probabilities of grouping? So probably if you have 20 of those, maybe 9 of them in a row could be overestimated.
Yes, they could. Yes, they could. There is going to be a situation where that happens. But on average, is it going to happen? That's the question. And that's the question you don't have an answer for yet. You have to see data to answer that question. But they've got that for you. They've got that. It's a fantastic question. But you can't answer it with a static image like this. It might be that you guys underestimate every bar on your sample. It's possible. I didn't look at the raw data, so I don't know. But it's not likely to repeat that on average over time. We'll come back to that. Thank you. Very, very good point. Back to this, 3 to 5. 4. We're going to call it 4 for the same logic. 6 to 8. Good. So no longer do we actually have the data points 0 through 8. We now only have 3 data points, 1, 4, and 7, operating at different frequencies. We see 13 1s, 14 4s, and looks like 5 7s. That's what we've got. Cool? Awesome. Good so far. If you're still not okay with this, just give me, like I said, 10 minutes and we'll get back into it, I promise. Okay. Let's pull some centers off of this. Mean, median, or mode, your pick, your choice. I can't remember what we did last time, so let's do it again. Your call.
Mode.
Mode it is, Richie. What is the mode in this case? Why is it 4?
This is the most of all.
Good. Richie's eyes go right to the histogram. This is why the mode is nice to find on a histogram or a distribution. You look at it, you go, oh, the tallest bar. The tallest bar has the most occurrences of that particular, as Nathan said correctly before, it's the data point with the most occurrences. It doesn't mean it's the majority. In this case, it's not, is it? No, because there are more non-4s than there are 4s. But it is the single data point that has the most occurrences. And notice we missed our true mode in the raw data, didn't we? Because of that goofiness that happened in this bar. But that goofiness is not average. You'll see why momentarily. So yeah, this bar is the highest. Therefore, this is our mode. And you can say the mode is 3 to 5 if you want to. I just want to get you guys kind of programmed into talking about what's called the class mark. So over there to our key data. Over there to our key data, let's list the mode as, we'll make this a different color, make it blue. For the grouped data, the mode is going to be a 4. So we missed it. We're in the wrong bar for the mode. But you know what? Honestly, that doesn't bother me. That doesn't bother me one bit. I'll get back to why momentarily. But that doesn't bother me a whole lot. We don't use the mode. I personally don't use the mode unless I absolutely have to. And there are some times when you have to. And usually when you have to, it's not a situation like this. So that's kind of cryptic. Within an hour, he'll understand what the hell I'm talking about. Good! Let's pick another one. What's next? Your call.
Median.
Median.
Amaya.
Amaya, thank you. Let's back out, start.